Hi friend, you are welcome back to Physarding. And in today's video lesson, we shall be learning how to correctly balance chemical equations. So without wasting your time, let's get started. Now for balancing chemical equations, there are some rules involved. And I pick out two most important of the rules to keep at the back of your mind. The first one is that always balance metals before balancing non-metals. Now the next is that hydrogen and oxygen must be the last thing you are going to balance. And at the same time, ensure you balance hydrogen before you balance oxygen. But the most important thing is that you balance them last. Alright? Good. Now, another important point you must have at the back of your mind. Never you alter the subscript in any of the chemical constituents that was given. Okay? Only adjust the coefficient. Now, let's say what they call the subscripts are normal like 3, 2 that are attached to the atoms of the elements in the compound. Don't alter them. Only the numbers in front of the compound, which are the coefficients, are what you should alter in order to balance the equation. So now we have these few tips and important tips at the back of our mind. Let's see how to balance this very question. So let's get started. Solution. Now for the purpose of balancing, I will be making use of what is called an atomic count. Okay? Whereby I'll be comparing the number of atoms of each of the elements on both sides of the equation. We'll be comparing them. So let's see. This is the original equation. So if we take an atomic count, comparing left side to right side, okay? Comparing the left side to the right side, let's see what we have. This is the left hand side and this is the right hand side. Alright? Now you have potassium. Okay? Now why am I writing potassium first? Potassium is the only metal in this side, is it not? Now, after potassium, they said balance metal before non-metal. So this is the only metal, I've written it out. Now what is there any non-metal in this side? You have chlorine and oxygen. And like we said, ensure you balance the other non-metal before you balance oxygen and hydrogen. Is it not? So that's why I'm balancing chlorine before oxygen. Is that clear? Good. So I will continue again. Now on this side, on the right side, we also write KClO. So this is what we now have. Now how do we balance this guy? Looking at it critically. How many atoms of potassium do you have on this side? It's just one. Is it not? How many on this side? Is there any subscript? No. Is there any coefficient? No. So it's just one. So if you see, by main comparison, potassium is equal on both sides. Is it not? It's already balanced. Then chlorine on this side, you have just one atom. There is no subscript and there is no coefficient to affect it, so it's just one. Then on this side, no subscript, no coefficient, so it's just one chlorine atom. Are you seeing that? Now for oxygen, on this side, there is a subscript 3. There is no coefficient, so they have 3 atoms of what? Oxygen. Then on this side, there is a subscript 2. There is no coefficient, so it's just 2 atoms of what? Oxygen. Now if you observe this, the metal potassium on both sides is already balanced. Same with the non-metal chlorine. So we have just oxygen to balance. Now observe 3 and 2. Is there a number I can use to multiply this and this that will make it equal? The answer is I will use 2 to multiply this and I will use 3 to multiply this. So we have 6 and 6. So the guy that is carrying this oxygen on this side, I will use 2 to times the whole of it. So how will it look like? Watch out, watch out. It will be 2. Who is carrying oxygen? Is it not this O compound? 2ClO3. Are you seeing that? Giving rise to 3 will now times the guy carrying oxygen on this side. And oxygen is carried by this component. Is it not? So it will be 3 times this. So it will now be KCl plus 3 times this. That is 3O2. So this is what we now have. Once you are here, you take another atomic count. Okay? Let's take another atomic count on this side. Now this is the left hand side and this is the right hand side. Now watch out. How many atoms of, okay, let's write the same order is what we use here. Okay, it's the same order we are using. We are not altering anything that much. We are using the same order. Now we also have K, Cl and O. Now how many atoms of potassium? Is there a subscript close to the potassium? No. But is there a coefficient? 2. So it will be what? 2 atoms of what? Potassium. Now, on this side, how many atoms? Is there a subscript? No. Is there a coefficient? So to just be what? 1 atom of what? Potassium. Then on this side, Is there a subscript for the chlorine? No. But there is a coefficient in front of the whole compound? Yes. So it will be 2 atoms of what? Chlorine. Are you seeing that? Then looking at this side, is there a subscript for the chlorine? No. Is there a number to affect the number of chlorine? No. So it's just 1. Then comparing the oxygen atom, is there a subscript? 2? Yes. Is there a coefficient? 2? Yes. So 2 times 3, in total you have 6 atoms of oxygen on this side. Let's check on the other side. Is there a subscript which is 2? Yes. Is there a coefficient which is 3? Yes. So 3 times 2 is what? 6. Now observe, on both sides, are they balanced on both sides? You have 2 here, you have 1, it's not balanced. You have 2 here, you have 1, it's not balanced. You have 6 here, you have 6, so this is balanced. So how do we now balance it now? Now go back to the first guy with the metal, which is potassium. Potassium is 2 here, potassium is 1 here. What do I do to make both sides balanced? I can simply come and times this side with what? 2. Remember, in this case, I multiply here by 2 and I multiply by what? 3. So any compound carrying this oxygen will go with a 3. While any compound carrying this oxygen will go with a what? A 2. Are you seeing that? So in this case, to make it balanced, I will times here by what? 2. Because if you times 1 by 2, it will become this same 2. So any guy that is carrying potassium on this right hand side will be times with what? 2. So how will it look like? 2KClO3 giving rise to, who is carrying potassium? It's not KCl. You will put 2 as the new coefficient. Are you seeing that? These 2 that you're adding, it will now be the new coefficient in front. 2KCl plus 3O2. Now let's take an atomic count. Though there's not enough space, but we can actually do it this way. How many potassium here? You have no subscript, but you have a coefficient. So it's 2 atoms of potassium. On this side, no subscript, coefficient of 2, so it's 2 atoms. So 2, potassium is balanced. Chlorine, any subscript? No. Any coefficient? Yes. So it's 2 chlorine atoms. On this side, any subscript? No. Any coefficient? Yes. So it's 2 chlorine atoms. Balanced. Then for oxygen, you have 3 subscripts and you have 2 coefficients. So 2 times 3 is what? 6 atoms of oxygen. You have subscript 2 and you have coefficient 3 for oxygen. So it's 3 times 2, 6. So this is the balanced chemical equation. And this becomes the answer to the question. This is the balanced form. So if I can, I'll be taking one more question on the balanced chemical equation. Let's have it now. Alright, here is the second question we are asked to balance. So let's do it together. It said, balance the chemical equation. You have C3H8 plus O2 giving rise to CO2 plus H2O. We are asked to balance this chemical equation. So first thing first, we'll take an atomic count of the original equation that was given. Okay? Before we even start doing our altering and balancing. So let's get started. Now, you will compare that for the left and the right hand side. Left hand side and right hand side. This is the left hand side and this is the what? Right hand side. Now, as I said, apart from oxygen and hydrogen, which should be balanced last. Okay? What other element do you have? We have only carbon. And carbon is a non-metal, so we'll just put it here, carbon. Now, like I said, after carbon, what should you balance next? You now have hydrogen and oxygen. Hydrogen and oxygen. Who are you going to balance first? Is it not hydrogen? Yes. Hydrogen before oxygen. So you write the same thing. CHO. Now let's take the atomic count. That means the number of atoms of each element on both sides. On this side, how many carbon are you seeing? If after the carbon you have a subscript 3. Now is there any coefficient? No. So the total number of carbon atoms is just simply 3 on the left hand side. Then on the right hand side, is there any subscript here? No. Is there any coefficient here? No. So it's just 1 atom of what? Carbon. Then going to hydrogen, on this side, there's a subscript 8 and there's no coefficient to affect this 8. So it's 8 total atoms of hydrogen. Is it not good? Then on this side, there's a subscript 2 and there's no coefficient. So it's just 2 atoms of what? Hydrogen. Then on the left hand side again, there is a subscript 2 after the oxygen. So oxygen is what? 2 on this side. Then watch out carefully for this side. In total, you have a total of 2 atoms of oxygen here. But there's still 1 extra oxygen here. Okay? 1 added to 3, to 2 is what? 3 atoms of oxygen. I repeat, you have a subscript 2 affecting this, showing that there's 2 atoms of oxygen. And there is no subscript here, no coefficient. So there's still 1 extra oxygen atom. So 1 added added to 2 atoms, you have 3 in total. So this is the original atomic count of the given equation. So let's start altering. We start with the non-metals in this order. Now you have 3 on this side, you have 1 on this side. What do I do to both sides? What do I do to make both sides equal? Can I times this side with a 3? So that 1 times 3 will also be what? 3 on both sides, is it not? Yes, I can do it, is it not? Now, this times 3 will now affect the compound that is carrying the carbon, and that is what? CO2. So I will put a coefficient of 3 in front of what? CO2. Are you getting it? So how will it now look like? It will be C3H8 plus O2 giving rise to what? 3CO2 plus H2O. This is now what we have. So we take another atomic count again. Okay, it's procedural. Left hand side and right hand side. So this is what we now have. Okay, now we have this. Ask yourself, let's take the atomic count. Following this pattern, CHO. You have CHO. CHO. So what do? Let's count now. For carbon, how many atoms of carbon? You have 3 atoms of carbon on this side. Then there's not a new coefficient of 3. Originally there was no subscript, but because of this 3, it will affect the number of carbon and make it what? Also 3. 3 times 1 is 3. Is it not? Good. Then for oxygen and hydrogen is 8. Hydrogen is what? 2 on this side. 2. Oxygen is 2 because of the subscript. Now this is now 3 times 2. Oxygen is 6. Added to this one, oxygen is now what? 7. Are you seeing that? 3 times 2 make it 6 atoms of oxygen here. But there's an extra oxygen, so that's now what? 7. 6 plus 1, 7. So this is not the new atomic count. As you said, is carbon now balanced? Yes, carbon is balanced. What about hydrogen? No. So, like I said, balance the hydrogen before the oxygen. See not? So what will I do to make both sides equal? Here is 8, here is 2. And maybe the only way you can alter these things by times. There's no that way. You don't add, you only times. So, can I say if I times this out before it will become 8? Yes. So I'll say times 4. Now this times 4 will affect the compound having the hydrogen, and that is this H2O, is it not? So I will put 4 in front of it. So let's do that now. It will now be C3H8 plus what? O2 to give rise to what? 3CO2 plus what? This 4 will now be in front. 4H2O. So this is what we now have, guys. So what will I do here? I'll take another atomic count. Let's see what we now have. Atomic count. Left hand side, right hand side. So following the same pattern, don't alter it. Don't alter the pattern. Maintain it. CHO. CHO. So let's count now. For carbon, you have 3. Okay? On this side, you have 3 carbon atoms because of the subscript. Then on this side, you have 3 carbon atoms because of the what? The coefficient. Then on this side, you have 8 atoms of hydrogen because of the subscript. On this side, you have 4 times 2, 8. Are you seeing that? Then for oxygen on this side, you have 2 because of the subscript. Then watch out, watch out. This is 3 times 2, 6, is it not? Now, 4 times 1, that is in, for the oxygen. You know there's a subscript 1 here, invisible 1. So 4 times that 1 is what? Plus 4. So 6 plus 4 is what? 10 atoms of oxygen in total. Are you seeing that? So I will say 10. So this is the new atomic count. So let's go through it and evaluate. Carbon is balanced. Hydrogen is not balanced. Now oxygen is not balanced. Like I said, the only way to make anything balanced is by using times. There's no that way. Now you have 10 here, you have 2. Can I multiply this left hand side with 5 to make it 10 like this side? Yes. So the guy that is carrying oxygen on this side, we have a new coefficient of what? 5, is it not? And that is this. So I'll put 5 as the coefficient. So how will it look like? C3H8, then what? Plus 5O2, then you complete the rest. Okay? So give 3CO2 plus 4H2O. Like I said, this is what we now have. So we'll take another atomic count. This is left hand side, then right hand side. Okay? Now let's do it. Following the pattern CHO. CHO. CH and what? O. So let's do this together. How many carbon on this side? You have 3 because of the subscript. Then how many carbon? You have 3 because of the coefficient. How many hydrogen? You have 8 because of the subscript. How many hydrogen? Watch out, watch out. 4 times 2 is what? 8. So it's what? 8 hydrogen atom. Then for oxygen, 5 times 2 is now what? 10. Then let's look at the left hand side, the right hand side I mean. This is 3 times 2, 6, hold it. Then 4 times 1, 4. So 6 plus 4 is what? 10. 10. So let's go through the atomic count. 3 here, 3 here, 8 here, 8 here, 10 here, 10 here. So this is now balanced. So we now say our answer is equal to what? C3H8 plus what? 5O2 to give rise to 3CO2 plus what? 4H2O. And this is the answer to the question. This is the balanced equation. I clearly hope you now understand how equations, chemical equations are being balanced. So back now guys, I'll be dropping one question for you guys to try your answer on. Let's have the question now. Alright guys, here is the question you are asked to balance. This is N2 plus H2 giving rise to NH3. And this is nitrogen gas reacting with hydrogen gas to give ammonia gas. Do well to try your answer on this question and feel free to let me know what you think the answer is in the comment section. Don't forget to share my video with your friends. Thanks for watching. I remain Ifizademi. See you in my next video.